Okay, let's start. Today we have more example about the waveform moment and MLE. Okay. So the first one is we have the S1 to Sn, they are the variables, and they have density like this, and we have to find waveform moment, MLE, and asymptotic variance. Okay. So, question 1. So the density is look at this equal to theta plus 1 x with power theta. Okay. And we know the x is from 0 to 1. Okay. And the waveform moment. So for this we have to find the average. Okay. This is from 0 to 1 x the density dx. Okay. So it's equal to 0 to 1 theta plus 1 x to theta plus 1 dx. Okay, we know how to integrate the polynomial function. So it's theta plus 2 x to theta plus 2 to 1. Yes, that's right. So it's to 1, so it's equal to theta plus 1 divided by theta plus 2. Okay. Okay, and we use the S bar to estimate the sample mean, to estimate the population mean. So its S bar is equal to the mm plus 1. Okay, so now we have to change the order. So it could be this plus S bar equal to theta mm plus 1. Okay, so it's 2S bar plus 1 equal to 1 minus S bar theta has mm. So theta has mm is equal to 2 power plus 1 divided by 1 minus S bar. Okay. Okay. B is MLE, so we have to find the negative function theta S1 to Sn, and this is equal to a product of density. So it can be theta plus 1 xi to theta plus 1, see, to theta. Okay. Yeah, only theta. Okay. Okay, so now we let's do some product si. Okay. We can find the log negative function, which is the log theta plus 1 plus n. Okay, so make a derivative. Okay. Okay, so when you solve the derivative equal to 0. Okay, get the n to theta plus 1 equal to negative. Okay, it can be like this. Okay, so theta plus 1. Yeah, that's reasonable. Okay, so log si negative and equal to theta plus 1. Yes, so minus 1. So it's a theta has ML is equal to minus 1. So summation si plus negative. Yes. Okay. And then we check the second derivative, which is equal to which is negative, so it's ML is MLE. Oh, for the positive, okay. Now we want to find asymptotic ML, and we know this is approximated by I of theta. Okay, so we have to calculate I of theta. I of theta is equal to negative second partial derivative of this. Okay, so let's calculate this. This is equal to log theta plus 1 plus log x theta. Yeah, I think so. Okay, yeah, theta. So the partial derivative of this is equal to theta plus 1 plus log x. And the second derivative of this is equal to plus 1 negative. So I of theta is a constant, which is equal to theta plus 1 square 1. So the values of the MLE can be approximated by this. Okay. Let's do the second question. The second question is a little bit different. The 1 and 2 is the same. 1 is find the maximum moment, and this is MLE. But for this one, they say find the mean and variance. So we have to find this rather than use the approximate. Okay, it's this, but not the. Okay, not this. Okay, so if the question tell you the asymptotic values, then you do this one. If it asks you to find the values, then you have to do this one. Okay, the equal to the property. Okay, so now we have the S1 to Sn. They are uniform little theta. Okay. So that means the density is look like this. Okay. Part A, we want to find the manifold moment. So for this, we have to find the mean. Okay, so this is this of theta x dx. Okay, so it's equal to 1 over theta. So it's equal to theta. Okay. Oops. Okay. So the theta hat Mn is equal to 2 delta S bar. And that's why we want to find MLE. Okay, so now first we have to find the Q function. Okay, and this is equal to indicator function x below to 0 to theta. Si. Okay. This is equal to theta to negative n power, and the indicator function Sn is smaller than theta. Okay. Okay. This one is equal. This one means the maximum value from 1 to n. So I from 1 to n. Okay. And this question is a little bit different than the previous one. It's because it's not differentiable. Okay. So because now you can see here is the indicator function. So the indicator function is not differentiable. So okay. So we have to be careful. In this case, the best way is you can draw a graph like this. So okay, if this is Sn, then you can see when theta is greater than Sn, the function is look at this. This is theta with negative power n. But the theta when theta is smaller than Sn, then it can become 0. Let's look at this. Okay. Then you can see it's obviously that the Sn is the maximum point. So you can know that the argument theta is equal to Sn. So that means this one is MLE. So Sn MLE. Okay. Okay. In part C, we want to find the mean and variance of MLE. So it's this and the variance of this. Okay. Okay. So before we want to find mean and variance, we have to find the distribution of Sn. We know Sn is the maximum point, but we have to find out what is its distribution. Okay. So this is the CDF for Sn, and if we can calculate the CDF and we differentiate of CDF, we get a PDF. So this is probability of S1 to Sn. They are all smaller than t, and that means this is like this to power n. Okay, yes. So this holds for all t below t to 0 to theta. Okay. And next we have to find the differential. Okay, guess the CDF, PDF by differentiate the CDF, and this is equal to okay, theta n to power n minus 1, and we have an indicator function. So for t below to 0 to theta. Okay, that's it. We have this is because when t greater than theta, the CDF equal to 1. And when t smaller than 0, the CDF is equal to 0. So the differential is always 0 when t is outside the interval. Okay, so we have this. And when you have a CDF, then we can find the mean and variance. Is equal to x n x to n minus 1 theta to power n. Like this. So this is equal to theta n x to power n dx. So equal to n plus 1 theta to power n is n plus 1 0 to theta. And this is equal to n plus 1 theta. Okay. And the values we have to find the second moment, then we will be able to find the values. So the second moment is s squared n, and this is equal to n theta to the power n x n plus 1 dx x, and this is n plus 2 theta theta. Okay, so we plug in the theta, we get theta squared. Okay, so the variance of the Sn is equal to this one minus the power of moment. Okay, yeah, so it can be theta squared n plus 1 n minus n plus 1 square n. Okay, like this. Okay, that's all. So please, you have to be careful about the question. So if it's as a totally variance, you have to find this, find the feature information. If we tell you to find the variance, then you have to do this.